These are the problems for section 1.4 of MA 104. We are going to start by looking at the addition and subtraction problems involving the complex numbers with the real and imaginary parts. We're asked to perform the indicated operations. In the first problem, we're asked to add the two complex numbers together. So that means we have to combine the real parts, which are 3 and 2, and the imaginary parts, which are 5i and 4i. Doing that, if we take 3 plus 2, that's just 5. And then if we do the same thing with the 5i and the 4i, add those together and we get plus 9i. This is standard form where the real part comes first, followed by the imaginary part. Same thing in number 21, but we have to be careful because there's some negatives here. We have the negative with the 3i and the negative with the 5 in the second complex number. But if I add those together, the 8 plus negative 5 is just equal to 3. And then the minus 3i plus 6i, negative 3 plus 6, is just positive 3i. Again, written in standard form, so we're done there. Finally, the third problem, we have to be careful about the subtraction. We're subtracting each one of these terms in that second complex number. So when I subtract, I'll be taking the 9 minus 6 and the 5i minus 2i. If I do those operations, I have 9 minus 6, which is 3, followed by the 5i minus 2i, which is again 3i. So we end up with that 3 plus 3i again. Some more of those types of operations. We have to be careful about the subtraction. I have 3 minus negative 5. 3 minus a negative 5 is the same as 3 plus 5, so that gives me 8. And then I have a negative 4i minus 6i, which altogether is negative 10i. Again, be very careful about keeping the subtraction sign straight. In number 27, I have a real number, the 2, that I'm adding to that imaginary and real number that make up that complex number, 3i plus 5. If I do the real components first, I have 2 plus 5, which just gives me 7. And then I have the plus 3i, which I'm just going to bring along because I don't have anything to combine it with. So my answer is 7 plus 3i. In number 29, I'm asked to multiply. I multiply the real numbers together, the 2 and the 4, and then I'll multiply the i's together, so I times I. 2 times 4 is 8, and I times I is I squared. Well, remember, anytime we see an I squared, we are going to replace that with negative 1. So instead of having 8 times I squared, that's actually the same as 8 times negative 1, which is negative 8. We have multiplication again. This time we're going to distribute. We'll distribute the negative 2 to the 4, the negative 2i to the 4, and the negative 2i to the minus 6i. We have to be careful about those signs again. Negative 2i times 4 is negative 8i, and negative 2i times negative 6i is positive 12i squared. Again, this I squared is negative 1, so this is actually negative 8i plus 12 times negative 1. If I clean this up a little bit and put it in standard form means that the real part should come first, so that 12 times negative 1, which is negative 12, I'll write first, and then I still have the minus 8i, which I have to bring along. So my answer is negative 12 minus 8i. Finally, I have two complex numbers that I'm multiplying. This is just that idea of repeated distribution. We just have to be very careful about keeping the signs straight. I'll take the 1 times the 3, and then the 1 times the negative 4i, followed by the 2i times the 3, and the 2i times negative 4i. Let's take this one a little bit slower and step by step just to keep everything straight. 1 times 3 comes first because I'm distributing that 1. After that, I'll take 1 times the negative 4i. So I took that 1 and I distributed it to the 3, so 1 times 3. And then I took the 1 times the minus 4i. I can't forget about that negative. Next, I'll be distributing the 2i. First to the 3, so I'll have plus 2i times 3. And then finally, I'll be taking that 2i and distributing it to the minus 4i. I can't forget about the minus. So plus 2i times negative 4i. It is really to your advantage to take this slow and to do this one step at a time so that you don't miss any signs. 1 times 3 is 3. Plus 1 times negative 4i is negative 4i. Plus 2i times 3 is 6i. Plus 2i times negative 4i is negative 8i squared. I can combine the negative 4i and the 6i. That's just going to be 2i. So I have that 3 plus 2i. Now remember, the I squared is the same as negative 1. So what I really have here is a plus negative 8 times negative 1. Negative times a negative is a positive, so this whole last term becomes plus 8. If I clean that up one last time, the 8 plus 3 is 11. And I still have the plus 2i. So my final answer is 11 plus 2i. We have more with the distribution. Again, you have to pay very close attention to the signs. I'll take the 3 times 4. Then I'll take the 3 times the plus I. So I'll have 3 times I. Next, I'll be distributing the negative I. I have to make sure that I bring that negative. So plus negative I, or the opposite of I, times 4. And then I have to take that opposite of I to positive I. So that will be plus negative I times I. Clean this up a little bit, and I get 12 plus 3i minus 4i minus I squared. But I squared is the same as negative 1. So this whole term is actually a plus 1, because minus a negative 1 is plus 1. If I clean this up by combining my real and imaginary parts, 12 plus 1 is 13, and then 3i plus negative 4i, or 3i minus 4i, is minus I. This next one, 37, these numbers are actually called conjugates, and they're going to be important whenever we go to divide. Conjugates have the same real numbers, the same imaginary numbers, but then the signs that separate them are opposites. One's positive and one's negative. When I go through the multiplication process, I'll distribute the 2, so I get 2 times 2, plus 2 times negative 9i. Don't forget about your sign. So that's distributing the 2. Then I'll take that 9i and do the same thing. So plus 9i times 2 plus 9i times negative 9i. If I clean this up, 2 times 2 is 4, plus 2 times negative 9i is minus 18i, plus 9i times 2 is plus 18i, and then I have minus 81i squared. Well, if you notice here, the minus 18i and the plus 18i cancel each other out. The I squared is the same as negative 1, so I actually have 4. The minus 81 times negative 1 actually becomes a plus 81. So I actually end up with 4 plus 81, which is 85. So taking a number times its conjugate eliminates those imaginary components and leaves you with just your real component, which in this case is a positive 85. That idea of conjugate pairs comes in handy whenever we're dividing. The whole point of dividing whenever we're dealing with complex numbers is to get the imaginary pieces out of the denominator. So to do that, I'll multiply by the conjugate, because I know that will bring out the imaginary. My denominator in this case is 2 plus 4i. The conjugate of that is 2 minus 4i. But whatever I do